integrated 3. It's problem 11-83. It just wants you to multiply these two fractions together. So when you're multiplying these, what you want to do is factor all 4 of them and then start canceling out common factors that you see in the numerator and the denominator. I'm guessing the reason this problem was asked is because it was a problem factoring them. Like maybe factoring is the problem that we're having. So I'll remind you how when you have a number, a coefficient other than 1 on your x squared, then when you make your diamond problem for factoring, you're going to multiply the coefficient of x squared by the constant. So 3 times -2 is -6. That's what goes on the top of your diamond problem. And then the coefficient of the x goes on the bottom. And then that's when you start thinking of what are 2 numbers that multiply to make -6 and add to make 5. And I was thinking 2 times 3 makes 6, or 6 times 1. I'm thinking 6 times 1. That would work. And then I'm going to take this information that I just found out, and I'm going to put it in an area model. So this polynomial right here, I'm going to put the squared term in the upper left. I'm going to put the constant in the lower right. And I'm going to put the 2 numbers I found in the corners. And it doesn't matter which way. It doesn't matter if I put the -6 on the top or the bottom. I'm going to put x's on them. And then I'm going to factor them by asking myself, well, it's the area model. Something times something makes 3x squared. Well, we know it's going to have an x times x. There's got to be a 3. I can put 3 up here, but then when I try to ask myself what times what equals x, I'm going to have that 3. It's going to give me problems. So I got to put the 3 over here. So 3x times x is 3x squared, and then 3x times something is -6x. So that's -2. And then x times what equals x, that'll be 1. So I think this factors into, I'm going to write it down here, x plus, here, let's do this. X minus 2. I'm writing in pen, so I can't erase. There we go. And then I'm going to do the same procedure down here and write my factored form. This one, I think maybe this is why people are asking this question. This one, these two have a common factor to factor out first. And this one, on top, you don't even do a diamond problem. But we'll do this little diamond problem a little bit faster now. So 2 times 15 is 30. And -11. So, I mean, 15 times 2 is 30, but I can never add those up to make -11. So 3 times 10 is 30. Those are never going to make -11. But 6 times 5. 6 times 5 multiplies to make 30 and adds if I make them both negative. So this will be -5x, and this will be -6x, and this will be 2x squared and 15. And then the 2 has to go on top because of the 6. And then this will be a -5. This will be, there we go. So now I've got 2x minus 5 and x minus 3. Now this is the one where the question probably came up. These two both have an x, so first you're just going to factor out an x, which will give you 2x minus 5. So you just look at both terms and you ask yourself, is there something that goes into both of them? And x does. So this one just factors as x. Notice the 2x minus 5. This one, we'll factor out the common factor up here, and then we're going to have to do a diamond problem as well, I believe. So if I look at all these three terms, I see that they all three have an x in them. So I'm going to take out the x, and then that gives me 3x squared minus 5x. Okay, so this one is going to factor like this. I need to do a diamond problem for this. So 3 times 2, negative 5, is it? Hey, this is the same exact thing as this one. So what does that mean? That means this will be, so I could have maybe taken a shortcut if I would have known that before I had factored this one. Right, because isn't this the same exact thing as we had up here? Can cancel them out right now. Okay, so I don't have to bother with all the factoring because I already know that that factored into these. Okay, and then now it's just a matter of going through and canceling out all the factors that you have on the top and the bottom. Well, this x and this x cancel out. This 2x minus 5 and this 2x minus 5. Here's a x minus 2 and an x minus 2 and a 3x plus 1. So we're left with a 1, just a 1 on the top. So maybe that's what's confusing. If everything cancels out, then you still have a 1 up there. And then this one is just x minus 3. So that was a fun one.